I'll just answer this question now before we get started. The content that private or like independent trials have should be the syllabus content, but they try to make it a little bit harder so that when you get into the HSC, you're prepared for anything, because we don't really know what the HSC is going to throw. So I know my trial was definitely substantially harder than the HSC paper that I ended up doing.
Cool. Once a few more people have joined, we'll just tell everyone to send questions and stuff into the Q&A, just because you'll be able to like see what other people have asked. If it's the same question, you can like upvote questions that you want answered and stuff like that.
Yeah. Today we'll mostly be going through like either past trial questions, just because it's a new syllabus, so the HSC questions are actually quite limited to what we had access to, but there's some HSC and some trials questions, and we'll go through some stuff that's probably a little bit harder than your average HSC question, just so you feel really prepared.
People had a lot of questions about ANU for Michaela the other day.
Yeah, so ANU does an early entry program, which has really like made a lot more domestic students interested, because it used to be like the biggest international student school.
Interesting. What do you mean by an early entry program? Isn't like,
so based off they give you like a predicted ATAR based off your year 11 results.
oh, okay.
So you actually get your offer in August.
Like before you do your exams and stuff.
Yeah, so it takes a lot of the pressure off for those finals.
Yeah.
So if anyone's got an ANU offer, definitely consider doing it. It's awesome. I love ANU. So
Awesome. That is, yeah, I haven't heard of other unis doing that. That's cool though.
Yeah, they started it for COVID and they kept it this year. So
I mean, that is honestly a good idea for COVID. Like, it's good that they did that. And then, yeah, might as well keep it. I feel like that would have really helped their admissions.
Yeah, especially since the international students like couldn't come to campus.
Yeah.
They just flooded it with domestic students who got early admission, which was
fair enough.
And it also takes the stress off the UAC process, because I feel like you guys have something similar, but ours is just like, oh, stressful.
Yeah, no, it is. It's always like the application process is always just a mess.
Like ordering your preferences and stuff. Like,
yeah.
I don't know what I want to do.
It's so tough.
Yeah. Okay. Do you want to give it another couple minutes, or should we just get started on some like intro stuff?
Yeah, might as well we can get started. People probably start like trickling in though, like over the next 5-10 minutes. Yeah, people are just joining now. So May can join for the intro. Feel free to start whenever you're ready.
Yeah. Okay. Well, I'll just go through this stuff because it's not really mathsy stuff. It's just kind of introduction. So hey everyone, thank you so much for joining. So today we're going to be doing Maths Advanced. If anyone went to either of our lectures yesterday, thanks for coming back. They were pretty awesome with our Business Studies and English Advanced. And if you haven't seen already, we've got our sciences on over the rest of the weekend. So chemistry is this afternoon, and then we've got physics and bio tomorrow. So if you take any of those courses, feel free to join those as well. Just a little bit about me so that you know what I'm doing, what I'm talking about. I graduated last year and I ended up getting 99 in my Maths Advanced exam in the HSC. Super unexpected, but also don't know where I lost the mark and still kind of salty about it, but it's okay, it's fine. I got into tutoring because if you can see that Snapchat, which I found from like my archives, my friends used to come to me with like their maths homework and be like, Emma, please help. And so I realized I was actually kind of good at it and thought I may like make a bit of a career out of it. Now I'm studying law and PPE at the ANU, and I absolutely adore that. And yeah, I'm sorry if you can hear a bit of an accent, or if I say math instead of maths. I grew up in America. It's just what it is at this point. Okay, so if we get started on our syllabus, what I was saying before, if you've just joined, is that 30% of your HSC is actually on year 11 content. So we've really got to like remember back all the way to the start of last year to what we were doing then, plus all of this stuff. None of this should be particularly surprising as your exams are coming up fairly soon. But yeah, just functions, trig, calculus, financial maths, and stats. And again, shouldn't be surprising, but if you're not aware, the exam is on the 15th of November. I really feel for you guys. I finished my HSC on the 9th, which is your first day. So definitely being drawn out a little bit longer, but get keen. Only 30 more days of maths and then you're done forever, unless you do extension. But yeah, that was some photos of me doing math study in year 12 and being sad because I didn't want to finish maths and I wasn't doing it in my degree, but it's okay. So an overview of what we're going to cover today. We've got 4 content blocks. Oh, we've got 4 content blocks. So the first one, we're going to do a bit of that year 11 stuff just to kind of warm up. It's not particularly challenging, quite a few multiple choice questions in there. And then we're going to go on to some graphing stuff, which would have been the first thing you covered in year 12. So then we'll take a bit of a break so that it's not too much at once. And you can ask me any questions that you have in the Q&A section. Then we'll go on to trig and calculus, and then have a bit of a longer break in the middle. Do some integration and stats, and then to conclude we'll just finish off stats and do a bit of sequences and series. So if everyone is ready to go, I'm happy to get into the first question. So what we're going to start with is, oh, I don't know why that says inequalities, ignore that. This is a question about the domain of a function. So what we're looking at here is the property of having this root in our denominator. So if you remember, if you can stretch your mind that far back to what we did in year 11, we know that there are 3 things that can limit our domain. So we've got, if we have root x, if you don't believe me, try and put a negative in your calculator and do the square root of it, you will get a math error. So that's going to give us an asymptote on our graph and will limit our domain. If we had 1 over x, again, if you don't believe me, try and put a 0 in your denominator and you will get a math error. And then finally, if we had a combination of those. So obviously what we can see in this question is we have a combination of both the root and the denominator. So from this, what we can look at is we know that if we had a root, x needs to be bigger than or equal to 0 because we can't have a negative there. If it was in the denominator, x cannot equal 0. So then if we put these 2 things together, we know that x has to be greater than 0. But what we have under in this question is not an x, but an x plus 3. So if we know that for a normal one, we have it has to be greater than 0. When we apply it here, we have to add the 3 to this side, and then we can subtract it, and we get this. So our answer would be A. And that's more or less fairly straightforward, but just thought we'd do a bit of a warm-up question to get you in the maths mindset. Okay. Our next question, Manoj, if you can launch a poll just to see if you can try and do this one by yourself. It's a rationalization question. So what we're going to do here is we want to make sure we're basically timesing our fraction by 1. If that gives you a bit of a hint of where to start, I'll give you a couple of minutes until we start getting some responses to the poll. If you're really stuck, just say no, and we can get going on the question anyway.
All right, we'll give them like another 20 seconds or so, and then I'll share the results. I think most people are doing it or done.
Yeah, awesome. So Remember, we're timesing by 1 if this gives you a bit of a hint.
All right, cool. I think most people who've answered are done, so go for it.
Okay, awesome. So our first step, we're gonna do our fraction, and we want to get rid of this root in the denominator. So to do that, we're gonna multiply by 1 because it doesn't actually change anything about our answer. It just makes it in a form that we can work with. So then we end up with 8 minus root 27 all times root 3. And then if we did 2 times root 3 squared, that's just going to give us 3. So we have 2 times 3, which is 6. And then what we have to do from here is expand our brackets. So we get 8 root 3 minus root 81 all on 6. And we know that root 81 simplifies down to 9. So we end up with 8 on 6 root 3 minus 9 on 6 here. And then we want to find what our A and our B is. So our A is going to be this constant here, which we can simplify. And then our B is going to be this constant here, which we can also simplify. So then you write, therefore, A equals negative 3 on 2, and B equals 4 on 3. Okay. So again, that was just a bit of revision of rationalizing. And whilst that is year 11 content, if you get a question with your answer has a root in the denominator, you are going to need to rationalize it to get the full marks for that question. Otherwise, your answer will be marked as incomplete. Okay, now this one is seriously stretching your mind back. I remember when I did this, I was like, discrete random variables, what the heck, in year 12. So if we could get a multiple choice poll going, I'll give you a couple minutes to try and work out the answer for this. My clue to you is think about what do the probabilities add up to? So I'll give you a couple seconds to think about that. If you're unsure, don't worry about it. As I said, I was also fairly confused when I tried to think my mind all the way back to this topic, which we did fairly towards the beginning of year 11. How are the results going, Manoj?
We'll probably give people another 10, 15 seconds to answer. All right, cool. I might share our results then.
Okay, awesome. So we've got quite a split here. I feel like this was definitely a tricky question. So the first thing that we have to do, what my little clue was trying to get you to think about, is that if we have all of our answers for X and we know what their probabilities are, the probability has to add up to 1, because if you answered anything, it would be 100%. So what we know by that is that A plus 3A plus 5A plus 7A, which are all of our probabilities in the second row, will add up to 1. So if we do this, all of that adds up to 16A, and we get A equals 1 on 16. So for the people who answered A, which was 50% of you, that's probably the step that you got up to, but we're not quite finished yet. To work out what our mean is, the theorem that we have to use is the expected value. So this is where we multiply our X by our probability of X, and then we sum them up. So if you're wanting the rule, that's the sum of X times P of X. So if we did that, we would have 0 times A plus 1 times 3A plus 2 times 5A plus 3 times 7A. We know that A is 1 on 6. So if we substituted wherever there is an A for, 1 on 16, then we would end up with 17 on 8, and the answer would be B. So good job to the 30% of you who got it right. If you weren't sure, we can definitely do some revision of this in some future tutoring lessons. Awesome. Okay, so let's go on to our second last question from our year 11 content, which is a short answer on probability. So I'll give you a couple seconds to get a head start on this. And if Manoj, you can put up a poll for the "Are you done?" That would be awesome. So for the person who asked in the question and answer, I'll just answer this one live. So you can put it in your calculator because that was a multiple choice, so they're not going to give you any marks for your working out. So that's definitely an option. I think it's probably super helpful if you know the theorem that actually, so you understand what you're doing rather than just plugging it into your calculator, but obviously up to you. Okay, so how are people going with this? Are we getting...
We've got a couple answers. We'll probably wait for a few more.
Okay. My hint to you here is going to be, think about what your probability of having at least one head and one tail would be. That's what your working is going to look like. That's your first. And then remember that property that we talked about of all our probabilities adding up to 1. Is there a way you can use that to try and work out what we're going to get here? How much longer do you think we need?
We will. All right, I think we've got enough. Let me share it.
Okay, awesome. So to do from here, what we're going to do is use that probability of 1. And we know that if everyone if we had 100% of the answers, that would be 1. So what we need to subtract is, what's the probability of getting no heads? And also subtract the probability of getting no tails. Because then 1 minus the probability of no heads and no tails is everything with at least 1 head and tail. So what we know from this is our probability of getting no heads for 1 round would be a half. And then because we have n times, we need to put that to the power of n. So each time the probability of getting no heads would be a half to the power of n. And then because we know that this is a fair coin, we know that this is the same for tails. So our answer would be 1 minus 2 times a half to the n. Awesome. Okay, so that was only a 1-mark question, but some people would get confused about where to use that n times. Now this is going on similar sort of concept, a conditional probability question. This was actually one of the questions in my trial, which I know a lot of my friends got super confused about and didn't end up having an answer for. So if you could give this one a go, Manoj, and you could put the poll up. And yeah, as you can see, I didn't put what the marks were allocated for A, B, and C, but it was basically 1 mark for A, 1 mark for B, and 2 marks for C, or something like that. Again, this is another question using that property of, if we only have eggs with white shells and eggs without white shells, what would that add up to? If those are our only 2 options, what would the full probability be? Just give me a shout when you think we're ready to go, Manoj.
I think people are still working through.
It's a bit of a brain teaser because you need to use your algebra and calculating the probabilities here, because we don't actually know all of our variables.
Do you just want them to answer A or all 3?
Well, if we work through A together, it'll probably make the other two make a lot more sense if they're a bit confused on the first part.
Go for it.
Okay, so if we start with A, what we're looking for, again, you want to make sure you're writing out what your probability you're using. So we want the probability of having a white shell. And then we know that if we had it from farm, assume that 3/5 of all eggs from farm A is going to be white shells. And we're saying that that's P. And then if we had all the ones from farm B, remember that all of our eggs are coming from either farm A or farm B. So we're using that property of them being adding up to 1. And so we have this sort of half finished equation here. But then what we're going to go into is we're going to simplify that. So we have 1/5 times 2p plus 1. Now I skipped a couple steps in there, but if you multiplied it all out, and so you did 3/5 p minus a fifth p, you get 2p, 2 on 5p, and then you put the fifth out front, and yeah. Awesome. Okay, so that should hopefully help you get an answer for B. What a lot of people would get stuck on with this one is actually remembering the formula, because it's not as straightforward as just knowing what your probability is, because it's a conditional. So we have A, and that little line means given B. And so our formula for this is we have to find the intersection of A and B divided by the probability of B. So in this case, we know that another egg is selected at random, given that the egg has a white shell. So that's what our B is going to be. The B is having the white shell, which we calculated in part A. And then we have to look at, find in terms of B, the probability that it came from farm B. So what we can look at with what we've already calculated in part A is that this is the probability here that it came from farm B, and this is the probability of it having a white shell. So we have 1/5 times 1 minus p, that's our intersection of it having a white shell and coming from farm B. And then over the total, we've got 1/5 times 2p plus 1. So that simplifies to 1 minus p on 2p plus 1. So it's using, once you've got the formula, you can think, okay, what's the intersection? And then what's the total probability of it having a white shell? And that's how you get the answer to that. I'm just gonna, I'm running out of space to do C. So I'm just gonna erase the first part, because hopefully you've all got that now. And I'll put this up here. So to do C, what we're looking at is, we know what if the probability that an egg came from farm B is 0.3, calculate the value of P. So this is just subbing in what we already know. So if we had 0.3 over our answer from part B, and then we have to just use our algebra skills. So we do this. And then so yeah, just once you know what you're making what equal what, then we have this. Awesome. Okay, so if everyone is comfortable with that, year 11 is probably the most difficult stuff to remember, in my opinion, because it was so long ago and you probably haven't been doing too much study on it. But that is what we're going to conclude our year 11 section with and move on to the functions section of our syllabus. So this is probably the first thing you did, and it builds on from when we introduced functions in year 11. And here we're looking at a composite function that we're going to graph. So for part A, we want to find the value of f of g of 1. So if Manoj, you could put up the poll for that. And I'll give you a couple of seconds.
I'll let you know when we've got a few answers.
So if you need a hint, if you're getting a bit stuck, my tip to you is to calculate what g of 1 would be first and then sub that into your f of x.
Cool. I think you can go for it.
Awesome. So to begin with, as I said, we want to calculate what g of 1 is. So that's going to be 2 over 1 plus 3, which is 2 and 4, which is a half. And then all we have to do from this is we now have to do f of a half, because that's what g of 1 is, and that's what the question is asking us for. And so we do 3 times a half minus 4, and we end up with -5 on 2. And that's the answer to part A. Now I'm just going to zoom in on our graph so we can sketch this together. What's slightly confusing about this to a lot of students is they don't calculate what g of f of x is first, but once you work it out, it's fairly straightforward. So if we have g of x, what we did in our first step was we plugged in the what we calculated first. So we're going to do the same sort of thing. So we know that f of x is 3x minus 4. So we're going to plug that into our g of x function. Now, what we know is when we change what's inside the x part of our thing, we're going to need to go into our g of x function, and wherever there's an x, we're going to need to change it the same way. So here we've multiplied our x by 3 and subtracted 4. So we're going to need to do the exact same thing to our whole g of x function. So we're going to go equals 2 over, and then the x is what we're changing. So we're, instead of having x, we're having 3x minus 4, and then we're adding 3. So what our function ends up looking like is 2 over 3x minus 1, remembering this condition here that the question has given us. So x does not equal 3. Because you can't change it just because we've changed the function here. Now, what a lot of you will have recognized from our graph is that this is going to look like a hyperbola. And to work out what our vertical asymptote is, we need to apply that condition we learned in year 11 of the denominator not being able to equal 0. So if we calculated that, we're going to have an asymptote here at x equals a third. And then if we subbed a point in, we know that if x equals 1, y also equals 1. So we can put that as our first point. And then if we wanted to find our y-intercept, we would make it where x equals 0, and that would give us -2. And then we can draw our arms into this function like this. And when you're doing a hyperbola, this is a dodgy graph because I'm just doing it on my iPad. In your exam, you'd have to make sure that it's approaching the x-axis a lot neater. And you also have to make sure that what my teacher called, you have to pin down each of your arms. So it's not good enough to just pin down one. You have to make sure you pin down both of them. And you have to label your function, which is this here. And that's what you would need to do for your graph. And then for the last question, we're doing solve this equation. So it's again applying the same principles that we've already looked through for part A. So we need to put inside of g of x, we've already calculated what g of f of x equals. So we know that this is going to look like this. And then we just want to set that equal to 6. And so we're going to multiply across. We're going to have 2 equals 6 times 3x minus 1. And then we're going to solve that, which will give us 6 times 3x, which gives us 18x minus 6, and 2 on this side. And I'll just draw like myself a little column to finish the question up the top. Oh, sorry. And then we want to subtract the 6 to the other side, so you get 8 equals 18x, and x equals 8 divided by 18. Okay, awesome. So this question was from a 2020 trial paper from one of the private schools on the North Shore. So it was intended to be harder than what you'll probably get in the HSC. As you can see, it was also one of the final questions in the exam. So it would be quite difficult. Just to answer the question in the chat, what do I mean by pinned down? What I mean is if you look how I've put a point on each of the arms so that it's not just like floating, you have a point at least on each arm. So normally you just have to put like one point in, but because there are two arms, you have to put a point in each. If that makes sense. Okay, awesome. So if we go back to this question, it's quite a complicated question. I'll just zoom in while you're giving some time to answer that. And you can see what you can do. This is kind of using your skills of calculus as well.
I'll let you know when we've got a few more answers.
My hint for you here, if you're getting a little bit stuck, is try subbing in these 2 points into your equation and seeing what you can do to solve it.
Cool. I think you are good to go.
Okay, awesome. So for part A, we have 2 variables. And when you have 2 variables like this, when you have 2 variables, we're gonna need to have 2 equations to be able to find both of them. So we know that our function is y equals h over x squared plus k. And we've been given the points 5, -1, and 0, -6. So we're going to sub both of these into our equation. So we have -1 equals h on 25 because 5 squared plus k. And then we have -6 equals h on 0 plus k, which is just h on k. And so I'm going to work these out at the same time, but if it makes more sense for you, you can just draw a line and do one and then do the other. So we'll then end up with -25 plus k equals h and -6k equals h. Now what we can see here is that we're going to get a simultaneous equation. So this I label 1 and I'll label this 2. And then I'll write so my markers know what I'm doing and I'm making it super straightforward. I'll say equate 1 and 2 because we have our h here and our h here. So these equations are going to be equal to each other. So we have -25. Oh, sorry. We have -25. I don't know why that's not erasing. We're just going to have to go with it. Okay. -25. I'll just put 1 plus k there because that equals the same thing. And then -6k. So this gives us -20. -25, -k equals -6k. I always like to have my constant in the positive, so you try and get rid of your negative so that you don't get confused later when you're dividing it out. So I'm going to move my k's this way. So I'm going to end up with positive 6k minus 1k, which gives us 5k. And then I'm going to move my 25 to the other side. And then you end up with k equals 5. Now, because we know that k equals 5, we can then work out what h equals, because we know h is negative 6 times k. So then I will write, therefore, h equals negative 30. And so now what we have is we have our full function. So we have h, and we have x squared, and then we have plus k. So that's what our function is now going to look like, and that makes everything a whole lot easier to work out from here. So I haven't really given myself terribly much space because the question was quite long. But for B, we want to work out that if Q has the coordinates of alpha comma 0, find the coordinates of R in terms of alpha. So let's look at our diagram. We know that this is going to be alpha comma 0, and then this is the point we're trying to work out. This is our question mark here. So if we work this out down below, we've got our function y equals negative 30, and we're subbing in our x value, which is this alpha. So then we have alpha squared plus the k, which we worked out was 5. And we know that our y value here is 0, so we know that this function equals 0. And from this, what we're gonna do is we are gonna work out what we have for R. And so because here we know that our property of a rectangle, this is gonna be a straight line down, our x value is gonna be the same, but our y value isn't. So this is still gonna be alpha, but this is gonna be our question mark here. So then instead of having 0, we wanna work out what it's going to be. And because we can't do anything more than what we already have here, in our coordinates of R in terms of alpha will be R is alpha minus 30 on alpha plus 5. And in our next step, we can work out what that is in more detail. So from here, for part C, we know that this is a rectangle, and our area of a rectangle formula is our length times our width. So we're going to use this property. Now we know that our symmetry lies around the x-axis. So if this is alpha this way, this is also going to be alpha that way. So we know that our length is 2 alpha. And then from that, we have our width. And our width is going to be what we can calculate our distance here is going to be, which we know that this is going to be width equals h over alpha squared plus 5, k 5 from what we worked before. And because it's a length, it's going to be the absolute value. So when we go into more detail in what our area is, we're going to sub those two in, and we're going to end up with, we're going to multiply our formula by the 2 alpha, so length times width. And this is going to give us, if we sub in our values from before, we'll end up with 60 alpha on alpha squared plus 5. Okay. And the reason why, because we had negative 30, but we've got the absolute value here, so our h isn't going to be negative, it's going to be positive. And yeah, that's the end of that question. There is also a part D to that question, but I haven't put it in. As to the question about, is this the level of difficulty we should expect in the HSC? I know for my grade, the question that people found the most difficult was the infamous cricket question, which I would say is a similar difficulty to this, but you should only expect 1 or so questions that would be this kind of difficulty, not the whole paper. So I'm just trying to prepare you for the worst so that when you get in there, you're not struggling. Part D wanted you to find the maximum area, but I've cut that off in this question, so that's okay. We can, that's why it was 7 marks if you were just wondering about how the mark allocation worked. Awesome, okay, so now we're looking at our last question before we go to a break. And this one is an exponential graph. So as I said, this is probably going to be one of the harder questions on the paper. As you can see, it was question 39 on this trial paper, so it's right towards the end. And I'll give you a minute or so if you could put the poll up to see how people are going with this. My tip for you here is that we need to use integration, and the rule is going to be one obviously to do with our log. So how do you integrate something to get a log? If that's confusing, how do you differentiate a log? What is your answer to a differentiated log? How are people going? I'm just cautious of the time.
We'll give them a couple more, wait for a couple more answers. Cool. All right. I reckon that's quite a few answers.
Okay, so to find out what this area is, what we're going to need to do is we're going to have to use our integration, as I hinted at before. And the property here that we have of k being greater than 0, we know that k is going to be our upper bound and 0 is going to be our lower bound, because that's where our graph starts here. Okay, awesome. So then our function that we have, which is on the picture, sorry, I didn't write it down below, is e to the power of x minus e to the negative x divided by e to the x plus e to the negative x dx. Now, when we have a fraction, there are a few different ways we can do it. There's something called like year 7 fractions, which is really just like simplifying and splitting them out. But here what we're using is our property of having the integral of f dash x over f of x to get ln f of x. So what I mean by this is if we look at our denominator here and we make that set equal to f of x, so this is f of x, what would be the derivative of that? It would actually be what we have on our numerator, which is e to the x minus e to the negative x, because we would take this negative down here and this would remain the same at the front. So this is our f dash x, which means we actually don't have to do anything to manipulate it to get it into the form that we want, which is perfect, makes life easier for us. And so then what we would get for our answer is we would end up having our big square brackets, because we need to use our bounds. We would have ln e to the power of x plus e to the negative x, and then we have to substitute in k and 0. So what we have now is, let's substitute in k. So we have this equals ln e to the k plus e to the negative k, and then we're subtracting what our lower bound is. And remember, anything to the power of 0 is going to give you 1. So if we had e to the power of 0 plus e to the power of 0, we're going to end up with 2. And now the property that we're using here in our log laws is if we have a subtraction, we can divide inside our log. So we end up with e to the x plus e to the negative x all over 2. And what markers really like to say is if we look back over here, we know that we have our area, and so we go ... as required. Sorry, when I was writing out the question, I accidentally put this back on the bottom, which I shouldn't have. It was supposed to be 2. So if you say ... as required, then they know that you've answered the question how you need it to. Okay, and then part B is find the simplest value of k if the area is 1. 1 equals ln e to the x minus e to the minus x all over 2. And then what we need to do here is work this out. So if we wrote this out in like our full form, we know that this is log to the base e. And so our trick here is we're going to do our base to the power of this answer here, 1, and then that equals what we have here. So we have e to the x minus e to the minus x all over 2. And so if we have 2 in our denominator, we're going to multiply both sides by 2. So we get 2e equals, sorry, not x, this should be a k. So then we have e to the k minus e to the minus k. And from here, we can put them all on the same side. So I'll just put in a column, and we have we have 2e equals e to the k. And then what our rule is with this negative is we can make it into our denominator. So we go 1 over e to the power of k. And then what we have to do is we don't want that in our denominator anymore. So we're going to multiply everything that we have by e to the k. So we'll end up with 2e times e to the k equals e to the 2k, because we have that k and we're squaring it. So we have to multiply. And then we have minus 1. And as I said, let's put it all on the same side. So we end up with e to the 2k minus 2e to the e to the k minus 1, sorry, equals 0. And what we can see here is that we now have a quadratic. So if we make, to simplify things, if we did u equals e to the k, then what we're going to have is u squared minus 2e u minus 1. And we can solve that out. So you would use your quadratic formula just in terms of time. I'm not going to write out the whole quadratic formula. You should know what that is. And then you would end up with e plus minus e squared minus 1. And you can type this into your calculator to work out what it is, but both, if we add or subtract that brackets, we're going to have a positive number because we know that e has to be greater than k, but because they're both positives, we end up with the 2 answers there. Okay, now we're on a break, so I'll just give a second and I'll look at the questions. Yeah, sorry. Isn't it k? Sorry, that was just my mistake. Thank you for pointing that out. And then would this type of question be towards the end of the HSC paper? Yeah, it definitely would be towards the end of the paper. I'm trying to give you as many like complicated questions as possible, because then you know to prepare for the worst rather than just think everything's going to be smooth sailing. And I'm not sure how many, it really depends on the paper, but you're all going to be sitting the same paper. So if there are a lot of difficult questions, then obviously the average is going to be lower. So I wouldn't worry too much about how many questions are going to be that type of difficulty. Awesome. Sorry. Yeah, I can go back to the past slide. That's a super messy thing. I'm gonna be, when we send out an email afterwards, I'll probably upload my answers document so that you can see it with the whole quadratic formula and like solving it to get the answer there. But yeah, I was just running out of space and time. Okay, awesome. If you could just like let me know when you're done with that slide, I'll move on. So just a question in regards to your ATAR, where your internal marks the same or close to your externals. Yeah, so I think I ended up ranked 2nd in Maths Advanced at my school when we finished internals. And so yeah, my internals were, because I went to a very competitive school, our exams were a lot harder, but obviously that gets like ranked up if you know how they sub things. So it was like probably a lower 90s, and then because I ended up with 99 in the exam and the person who came first also got a 99, so that just like averaged out, and that was the final mark that we got for the course. Okay, awesome. Just because I am cautious of times, I know we said we'd give you 5 minutes break, but I'll give it like another minute, see what questions come through, and if there aren't any other questions, then we'll get on to our next content block.
Seems like no more questions are popping up in the Q&A, but we'll give them another couple seconds. If you guys have questions, just send them in the Q&A for everyone to see.
And just so you're like prepared for the next section, will the recording be sent to our email? We'll send you a link to our YouTube channel and it'll be uploaded on then, so you'll have access to that. Yeah, our next topic is trig, just in case you guys were wondering. Okay, are we ready to move on?
Go for it.
Awesome. Okay, so this is a trig equations question. And if you could put the poll up so I can see how people are finding it. So this, as you can see, was an HSC question, but from one of the older papers. So before the syllabus change, this has just been in both syllabuses, which is why I could use an old question. And this should not say 3, sorry, that should say pi. I just wrote it wrong. So just in terms of the question that we've just popped through, preparing for the exam, I would say if you have a textbook, the textbook should have chapter reviews at the end of each chapter. So if you're really struggling on a specific area or like type of question, I would suggest doing that. And the only reason why I'm talking about the syllabus a lot is so that you guys know what you're actually supposed to be, you're going to be examined on, but the textbook should have that as well. So that's probably good. The textbook, we used multiple textbooks. Trying to think of what their names were. The Cambridge textbook, and the, I want to say like New Maths or something, but I don't actually know if that's what it was called. And then our teachers also gave us lots of handouts and like revision papers. So also try and do as many like, if you can find like other people's trials online, like other schools' trials, that would probably help. But don't get too stressed out if they're like really intense difficulty, but definitely do the 2020 HSC paper. And then would you recommend doing questions from older HSC papers? So what my school did was they gave us HSC questions that were relevant to the syllabus. So like they screenshotted them and cut them into a document so that we weren't doing questions that weren't relevant to our syllabus. So yes, some of them will still be relevant, but not all of them. So just be careful if you run across something and you're like, what the heck is that? It's probably because it's been taken out of the syllabus. And also don't forget to do the new stuff that they've added in, like sequences and series and that sort of stuff. Okay, are we ready to get going on this question?
Yep, go for it.
Okay, awesome. So the first step that I would do to solve this is let's make our answer as simple as possible. So I'll divide both sides by 2, so we end up with a half on that side. And then we can square root both sides, remembering that this is going to be plus or minus the root of a half, which we know that root of 1 is just 1, so it's plus minus 1 on root 2. And then we need to draw our little diagram here of all stations to central. That's how I remembered it. And we're gonna use our properties of, sorry. We're gonna use our properties. We know that our domain is negative pi to pi. Sorry, I wrote that wrong on the question. And so we're gonna have to have the answers for our positive pi. So that's from 0 to 180. And we're also going to have, I would put this in a different color, but we tested it out and the only colors that PowerPoint seems to give us are like these weird ones and nothing else really works that well on this color. But let's just say if we had black here, those are going to be our negative answers. So for 1 on root 2, if you know what that is, it's going to give us 45 degrees, which is pi on 4. And then our other positive one is going to be 3 pi on 4. And now let's go negative. So it's going to be the same, but going the opposite way. So we've got negative pi on 4 and negative 3 pi on 4. So we've got x on 3 equals pi on 4, 3 pi on 4, negative pi on 4, and negative 3 pi on 4. And then all you have to do is multiply everything by 3 so that you get your x. And you can just do that in the numerator. And obviously these are all going to end up being fairly similar. So that would be that question there. Oh my god, I'm so sorry. Okay, so this is a graphing and integration question, and it's to do with trig because that's something that you learn in year 12 exclusively about how to integrate trig questions. So let's go with this one. Let's get a poll going, see how people are going. My hint for you here is to think about what our 10 does to our amplitude and what our pi on 6 does to our period.
Wait for a couple more answers, maybe like another 20, 30 seconds.
Okay, are we ready to go?
Cool. Yeah, go for it.
Okay, so I didn't give myself axes here, which is really annoying, and I don't have a ruler, so you're just gonna have to deal with my dodgy graph drawing. But as I said, we had to think about what 10 does to our amplitude. So if we're multiplying everything by 10, we're gonna be going up to 10 and down to negative 10. Remember, this is a sine graph, which looks like that, more or less. It's what my teacher called the snake one. And so our period is going to be multiplied by, so we're going to have to multiply pi on 6 by 2 pi, because normally we're going to finish at 2 pi, but here we're going to be finishing at whatever 2 pi times pi on 6 is, which gives us our endpoint, which is going to be 12. And so if our endpoint is 12, we know that our midpoint is going to be 6. And then we can draw in our like dots here so we can draw a graph. Again, if you were drawing this in the HSC, it would have to be a lot neater than that and not as pointy, but I'm doing this on a small space. So and then our next thing that we had to do is we had to draw in y equals x, which should be fairly straightforward for all of you because it's just a straight line. And remember what I said, we have to label our graphs. And I'm going to shade this area because for part B, that's what we're going to be calculating in there. And yeah, pin down your thing. So we've got when x is 12, we've got 0, and that's fine. And they wanted us to mark our intersection at 5,5. Awesome. Okay, so that's part A, and that's like kind of what our graph is going to look like. Now for part B, we're doing integration here. It was kind of given away in the way I entitled this slide for our area bounded between the two graphs. So the way I remember the rule for this is if you're doing the area between two graphs, you want to have your top minus your bottom. So our bounds are going to be from 0 to 5 because they gave us our intersection point. And then from that, our top graph, as we can see, is the sine graph. And our bottom graph is just x. And we have dx. So then from here, what we have to do is we have to integrate. So remember, we multiply our 10 by the inverse of what our x is multiplied by. So we're going to, and because sine integrates negative, if you find that confusing to remember, think of it this way. Sine integrates negative, it's in its name. And from that, you can work out what the differentiation and the cosine rule is. So we have negative 60 on pi times cos pi on 6x. That doesn't change there. And then we have to integrate this, which should be fairly straightforward for most of you, which is a half x squared. And then put our bounds in, and then we're going to sub that in, which again, just trying to go through this super quickly because you can more or less plug that into your calculator and work this stuff out. But we're going to end up with this. And again, they wanted it a simplified exact expression, so you can't just give a decimal. You're going to need to actually do all of this. And then I wanted, this is where your mark would be at this line, but I like to make sure that my equation is as simple and easy for my marker to read as possible. So we're going to need to times this by pi here, and we're going to need to times this 60 by 2 to get it all over the same denominator here. And then I'm running out of space. Let's just put it over here. So we end up with 60 root 3 plus 25 pi plus 120 all over 2 pi. And that's what this area is equal to. So just to remember that we're doing an area, you want to have your units squared at the end, because they haven't actually given us whether it's in centimeters or in anything else like that. So we just say units squared. Okay, this is a very similar question. So just in the interest of time, I'm going to move on to a calculus question. But of course, feel free to go back to that question in your own time. This was, I think this was, oh, sorry, I've got my answers in the wrong order. We're actually up to this question. This was the last question in my trial paper, and I was really annoyed because when I did the last step, I forgot to prove that it was a maximum. So remember that that's super important. You have to actually prove that it's a maximum, not just find the point. So I got the correct answer, but I didn't have all the proof steps, so I didn't get all 5 marks. I only got 4. So fair warning to everyone, don't forget to do that. And yeah, just react to the poll when you've had a chance to do it. How are we going, Manoj?
People are still answering. Couple, we'll probably give them another few seconds. All right. I think we've got a few answers. Cool.
Okay, awesome. So for part A of this question, we want to work out what the area of the rectangle is. So to do this, we need to try and let's annotate our graph a little bit. So we know that from here to here is y. And so because we've got that symmetrical property, we know that here to here is also going to be y. And then we also know that our radius is 4, which means our diagonal is going to be 2 times our radius. So that's going to be 8. And then as I labeled the 2 y's, we're going to have the 2 x's to go across the center of our rectangle there. Okay, so that's like the properties that we need to use. Now, if we have, so we have 2x is this here. Okay, so we know that we have 2x and we have 2y and we have our 8. So to try and get one variable instead of 2, we're going to use our Pythagoras theorem. So we've got b squared equals c squared minus a squared here. So for that, we have 2y all squared equals 8 squared minus 2x all squared, which gives us 2y equals root 64 minus 4x all squared. Now we've got a common factor under here, which is 4. And then because 4 is 2 times 2, we can take a 2 out the front and just end up with 16 minus x squared there. And because this is still equal to 2y, we can take out our common factor of the 2's, and then we end up with y equals this. Okay, so that's kind of like our first piece. Now we know what y is in terms of x. Now if we want to find what our area is, we know that our area for a rectangle is going to be our length times width. And we know that our length is 2x and our width is 2y. So we're going to end up with 4xy. And we know what y is in terms of x, so now we can just sub that in. So we have 4x times 16 minus x squared. And that's our answer to part A. And as this is a proof, we can do ... as required. That's the most satisfying part of a maths question, I think, because you know that you've got it right if you can get to that point. Okay, now what I was saying about the maximization is obviously in relation to part B. So we want to find our maximum area. Now to find a maximum, we have to use our first derivative. And what we're going to have here is a product rule question. So the derivative of A is going to be uv plus v u dash. And then when I do questions like this, I like to do it in a little table. So we've got our u and we've got our u dash, and then we've got our v and we've got our v dash. So from that, we know that u is 4x, so u dash is 4. And then our v is, sorry, I've run out of space. I'm going to do it down here. So we've got our v. To make it easier, I say to the power of a half, because that's what our root is actually telling us. So then v dash, we're going to have to use our chain rule, and we're going to get a half times 16 minus x squared to the negative a half, because we take away 1 from our power. And then we multiply it by our derivative of inside the brackets, which is negative 2x. So we end up with negative x divided by this here. Okay, awesome. So now that we have all our information, it just becomes a question of subbing it in. So we have this equals, we've got u is 4x, and then we have our v dash, which is this negative x divided by root 16 minus x squared, and then we have plus our v times space. Okay, hopefully you can see what all of this is already. So I'm just gonna, I don't know why the eraser isn't working. That's really annoying. Okay, so we've got plus v, which is root 16 minus x squared, and then we have that times by our u dash, which is just 4. Okay, so if we go over here, we can continue to work what that is. So if we have our maximum, that's going to be at our stationary point of a dash equals 0. So we can sub that in here. So if we have 4x times negative x, we're going to have our negative here. We're going to have it as squared. Then we're going to do this, 16 minus x squared, and then we have plus 4 root 16 minus x squared as well. And so we're going to times everything by a denominator to get rid of that. So we have to times that by 0, and 0 times anything is just 0. And then if we times it over here as well, then this is going to, instead of being square root, it's if you square root something and then you square it, that undoes itself. So you end up with negative 4x squared plus 4 times 16 minus x squared. And then from that, what we can do is we can either expand it out, but we know that our 4's are going to cancel out. So where do I have space? I'm going to draw myself a new column over here. So we can divide out the 4's and we get 0 equals negative x squared. We've got rid of our 4. So then we have plus 16 minus x squared. So we get minus 2x squared, and we can move that to the other side. Equals 16, divide both sides by 2. We get 8, and then we have the square root of 8, which simplifies to plus or minus 2 root 2. Okay, awesome. But as we know, x is a length. I don't know why this got rid of this up here. We know that x is a length, so x has to be greater than or equal to 0. And so we have x equals 2 root 2. And then I subbed this in and was like, okay, great, I'm done. But you're not done. You have to prove that this is the maximum x value. This is going to give you the maximum area. So you could either find your second derivative and prove that it's concave down so that it's a maximum point. But because this is more of a complicated equation, what I'm going to do here is I'm going to just put in a table of values. So we have our x and we have our y dash, which is a dash really. And so if we had 1, 2 root 2 and 3 and we subbed all of those in, we know that this is going to equal 0, this is going to be negative 0.3, and this is going to be positive 14.5. So I'm running drastically out of space, but well, we know that's going to have a positive gradient, a 0 gradient, and a negative gradient. So that's how we get our max point. Then to finish the question, you just need to work out what y equals. So we would sub that into this 16 minus x squared, and we get 16 minus 8, because that's 8 squared, root 8 squared, which just gives you 8. And so then we also get 2 root 2 for our y value, so it's a square. And then you sub that into your area formula, which we worked out was up here, the 4 times x times y. So we've got 4 times 8 basically, because if you're squaring it, then it undoes itself and you end up with your area. Oh my goodness. You end up with your area equals 32 centimeters squared. Okay, that was a really long question. As I said, this would be right at the end of the paper and you would only get one question that's this level of difficulty. But I think that deserves a break. So pop any questions in the chat that you have, grab a drink, do whatever you need to do, and then we'll get into some integration questions. Yes, I can go back. I'm sorry. And I'm sorry that this is so messy. As I said, I will give you back. I'll give you the answers in a document, probably in an email after the event, so that you can go through this with more logical working that doesn't simplify out any steps. Do you have any tips for time management in an exam? My biggest tip about exam technique is when you start your paper, you get the reading time. So go through and make sure that you know how to do anything. And if there's a question that surprises you, what I would say is take a deep breath, don't freak out. And when you get to that question, spend however much time until you get stuck or until you're getting really confused and overwhelmed. And if you start to get stressed, then that's when I would say take a break from that question and come back to it at the end, because you're going to get more marks for answering questions that you do know how to do than trying to struggle through a question and wasting your time on it. So that would be my tip for time management. Just do what you can do. Know, like during the reading time, identify what you know you can do and what you know is going to be challenging, so that when you get to that question, you don't freak out about it and you just keep going. So in the chat, I've got a question about if you have a good rank but flunk the HSC, does the rank sort of save you? So basically, yes and no. What you get in the HSC is your mark and that's it. You keep it, but you average your internal mark with your external mark. And so your internal mark is actually whoever, so if you're second, for example, your internal mark is going to be whoever in your school got the second best exam score. So say you got 95 in your internals, but the person who came second in the HSC got a 97, your internal is going to be bumped up to a 97, but that's only 50% of your mark for the course. The other 50% is whatever you got in the exam. So yes and no. If you got 97 for your internal and then you get 80 in the exam, it's going to average out to whatever the middle of those 2 points are. So it'll bring you up, but it just won't save you. Okay, I'll give another few seconds if there are any more questions that come through. What happens if you screwed up your trials? Do not worry. That is the first thing I would say. As I said, 50% of your mark for the course is literally just what you get in your HSC, so you can still bring yourself up heaps. So if you reverse the example I said and your internal ends up being 80, if you get 97 in the exam, that's still going to bring you up heaps. So just keep trying is my biggest advice there. Okay, our next topic is integration, if everyone just wants to prepare themselves. And I'm happy to get started in the next couple of minutes. Awesome. Also, if you do have questions and you're not worried about people seeing your name, then try and put them in the Q&A if you can. Otherwise, I am happy to answer questions from the chat. Okay, let's get going. So this is integrating a log exponential. So with this problem, I think the first step that you need to do is simplify what your function that you're integrating is. So if we could get a poll going, see how people go with this question. This was only 2 marks and it was towards the beginning of a paper, so shouldn't be take you too long. And yeah, just if you're finding any of these questions super challenging or you didn't expect it, do not freak out. Keep studying, keep trying, because I'm just looking at questions that would be challenging so that you can prepare for the worst, as I keep saying. This isn't going to be what the whole paper is like. There will be questions that are so much easier than these. Okay, how are we going, Manoj?
Pretty good. We'll give him another like 10, 20 seconds. But I do agree the best technique is to give like my tutoring students, what I do is I just give them super hard questions. And then after the exam, they're like, oh, that wasn't so bad.
Yeah, definitely.
Yeah.
If you're like reading, if the questions that you're doing in your practice are so hard and then the questions in the exam are easier, it makes you feel so much better about yourself.
Yeah.
You're like, I could do that.
Okay, I think that's most everyone. So let's take a look.
Okay, so our first step, as I alluded to before, is that we want to simplify this. So our root becomes a half. And so we're going to end up with e to the power of x over 2 dx. And then from that, this should become fairly straightforward. So we have to multiply our function by the inverse. So we end up with 2e to the x on 2 ln 9 ln 4. Okay, so what we get here is we then have to expand this out. So I'm going to write this as a half and then do ln 9 minus a half ln 4. Now, what we know about our logs is that if we have a half out the front of them, that can actually go and be like a power to the number at the end of the log. So that's like saying 9 to the power of a half, which is like root 9, which you should all be able to work out is to the ln 3, because that's what that is there. And then we have ln 2. And if we have e to the power of a log, those like undo each other. So we just end up with 2 times 3 minus 2 times 2. And we just end up with 2. So that was like more or less pretty straightforward. I'm going to put the next question up, and this is about finding the area between the curves. Whilst you do that, I'll just answer the question in the Q&A. I done them a month ago though. Okay, 16 trial papers. That is awesome. Good job for getting 16 done. I definitely did heaps of trial papers and I think it really helped. If it was a month ago, I know how hard it is to like with all this extended time, just like trying to keep your motivation up. if you feel comfortable, I would say that that's the main thing. You want to feel comfortable going into the exam. Probably try and do some more revision in like the week or so before the exam starts. But yeah, if you're feeling good, then that's the best indicator of your performance going forward. How are we going?
Let's give them a couple more minutes just so there's a few more answers to come through.
Okay, so we've got a question in the chat about your trial mark. I can't, in terms of answering this question, it really depends on your school and the difficulty of the paper. So if the paper that you did was super hard and the whole grade got a lower average, then the HSC will probably be easier and your marks will go up, if that makes sense. But if the average was really high for that paper, it probably wasn't that difficult and is more reflective of what you actually would get in the HSC. So it's really dependent on your school. And that's why we have ranks so that it's fair for everyone.
Cool. All right. I think we've got a few answers. Go for it.
Okay, awesome. So with this, we're wanting to find our points of intersection. So we can kind of see from this diagram that where one is going to be, but let's work it out. So we've got our first graph is this, and we want to equate them to find our intersections. So our second graph is that. And so then if we put everything on the one side, we end up with this. And then let's take out what common factors we have. And then what we're going to do is to get something that's 0, this should probably be something that you guys are aware of, but to make something equal 0, you have to multiply one of these has to equal 0. So we set 1 equal to 0, and if we set 2x equals 0, we know that x is going to be 0. And if we set x plus 4 equal to 0, we know that x is going to be, oh, sorry. What did I do there? Yeah, this should be a negative, and this should be a positive. Sorry. Okay, so that's what you're gonna get for your x, and because the question only wants the x coordinates of point A, which is this one here, we know that therefore the x coordinate of A equals 4. Okay, so now we want to find the exact area between the parabolas, and we've done this a little bit throughout this lecture, so hopefully you can kind of see where we're going here. But remember what I said when we're doing the trig one, we want to do our top minus our bottom, doing the integration. So when we have our bounds of 0 to 4, because those are our intersection points, the top graph is this one, and our bottom graph is this one. Now remember to make sure that because we're subtracting it, we have to put it in the bracket so that you remember to multiply that negative out to both terms. So then what we're going to end up with, if we simplify this, we're going to have 8x minus 2x all squared dx, and then we have to do our integration here. So we've got 4x all squared minus 3x cubed 4 and 0. Obviously anything times by 0 is going to be 0, so our second term is going to be nothing, but our first one is going to be 4 times 4 squared minus 2/3 4 cubed equals 53 and a third, or you could write 0.33, whatever works. And remember, we have to have those units squared there because it's an area. Okay, awesome. The next one that we've got here is our last integration question, which is about an acceleration. So if we do get the poll going, this is just kind of an application of what we're having to do here, and just remembering what the X with the weird dots looks like and what that means. My tip to you here is write out what you know. from the question. What does the question give you? Does it give you any points that we can sub in? And how would you work those out? If you're stuck, let's write out what we know. When t equals 0, x equals 0, and our velocity also equals 1. That's what the question has told us. If that helps anyone.
Probably give them another 10 seconds or so. Cool, go for it.
So yeah, in terms of exam technique, I think that this is super helpful, writing out what you know, because then you're like, okay, you got it in like math speak instead of in the words. And then our first step is we're gonna wanna work out what our velocity is. And to go from acceleration to velocity, we're gonna integrate. So the x double dot is acceleration, and then an x single dot is your velocity, which you can also just say equals v if that's easier for you to remember. And so the answer to this is we're going to have our integral of 4 cos 2t dt. Now in the examples we've done earlier in the lecture, we've had bounds, but this doesn't. So that's the all important c is coming out here. So we have this equals 2 sine 2t because cos integrates positive. And then we have plus c. Now, because we have our information at the top that we know when t is 0, v is 1, so we can sub that in. So we have 1 equals 2 sine 2 times 0 plus c. We know that if you think about your sine graph, 0, 0, so that's just going to be c equals 1. And therefore, x dot, or your velocity, whatever you want to call it, is going to be 2 sine 2t plus 1. Okay, so then our second part of the question is asking when it first comes to rest. So if something is at rest, that means that our velocity is going to be 0. And we also want to work it out when it's first at rest. So the hint there is that there's going to be multiple times where it stops and comes to rest, but we just want the first one. So we have v equals 0 equals 2 sine 2t plus 1. So if we simplify that, we're going to have sine 2t equals negative a half because we've moved our 1 over and then we've divided it by 2. So we then have, from that, if we want to, we're going to use our graph. So we have our all stations to Chatswood graph, and we know that it's a negative. So we're looking for wherever sine is negative, sine is positive in the first 2 quadrants. So we're going to be looking at these 2 quadrants down here. And because it's 2t, that means that we have to go around twice. So we're going to get 4 answers, and you can write all the answers out to show that you know what the theory is. But as we said, we just want the first one because it's when it first comes to rest. So we're going to have 2t equals 7 pi on 6. And then because we have it, we need to then divide it by 2. So then we're going to have, t equals 7 pi on 12. And that will be the first time it comes to rest. Now you could, because the question doesn't specify, you could then put that in a decimal, but just remember to add your units. I think leaving it in exact probably works the best. And then again, running out of space, which is super annoying, but let's try and find some space to do part C. So the displacement of x of the particle in terms of t. Okay, so if we've gone from our acceleration to velocity, our next step is to go down to our displacement, and that is x equals the integral of our velocity. So we just do similarly to what we did with our first part, except we're integrating 2 sine 2t plus 1 dt. And then from that, we end up with the sine integrates negative. We've got negative cos 2t plus c. We've got our point up here that we already talked about. So when x is 0, t is 0. So we have 0 equals negative cos 2 times 0 plus c. Oh my God, I'm running out of space. And we know that our cos graph looks like what we call this the monkey man, because he's like hanging there. But so when your t is 0, you're going to have cos equaling 1. So from that, you need to sub that in. So you end up with 0 equals negative 1 plus c. So c equals 1. And therefore, x equals negative cos 2t plus 1. And that is your displacement in terms of t. So it's really just an integration question, but it's remembering that you have to go from acceleration to velocity to displacement. And it's like that 3 steps. So that's the end of our integration section. Good job, us. And we're going to get on to some stats. Now, I don't know about you, but stats was something I was like, stats is so easy. I don't have to think about this. I barely wrote any notes on it. I was like, yeah, chill. Not as chill as we may think. So if we could get a poll going, just see who remembers what a probability density function actually is. In terms of graphing, the hint is really in the piecewise nature of our f of t. I don't know why I made this so small. I'll zoom in for you.
I think we'll give people another 15, 20 seconds. We definitely need to get like Kahoot background music next time.
Yeah, no, fair enough. That would be
cool. All right.
Okay, so with a probability density function, just to give you like a recap, if it's completely escaped your mind, our area under the curve is going to be equal to 1, because that's what we were saying before about our probability from year 11, 100% of the answers will lie under the curve. So with our piecewise, we know from 0 to 3 on 2, it's just going to be a straight line of a third. So that's all we have to do there. This is the third. And then from 3 on 2 to 9 on 2, we're going to have this function here. And when we work that out, if you sub 9 on 2 into the t there, then that's going to give us 0. So it's just a straight line like this. And because we also know that it's 0 otherwise. So all of this area is going to be equal to 1. So that's what our graph looks like. Now, this was also in my trials, and I was looking at my paper of how I did this. And what I mean by I did not revise stats at all was I did not revise stats at all. And so I spent literally like so long trying to work out what this median was, and it's actually super, super simple. And I did so much working and I got it wrong and I just wanted to like cry. But it's okay. We have learned from our mistakes. So for part B, we're going to think about this, and let's think of our area. So our area, we already know that it's going to be 1, but let's kind of prove it. So we're going to have a third times 3 on 2 plus 1/3 times 9 on 2 minus, minus 3 on 2 all on 2, because it's that triangle. And then that gives us 3 on 6 for the first part and a half for the second part. So that equals 1, obviously, right? But what's really useful about this particular graph is that we have 3 on 2 here as our point, and that, see how this is a half and this is a half? That's our definition of a median, where half of the scores are in front and half are behind. So we know that this area is half of our scores and this area is the other half, which means our median is literally just 3 on 2. If only someone could have told me that during my trials. Okay. And then what it wants us to do is find what the probability that t lines between 1 and 2. Again, another integration question. You're so welcome. What we're doing here is we've got the integral from 1 to 3 on 2 of this first part, because we've got to use this part of the piecewise and this part. So we have to do 2 separate integration parts. But we've got this and this, which is a third dt plus 3 on 2 to 2. So that's so we're going from 1 to 2. We just have to do it in 2 steps. And this is a half minus a ninth t. That's just simplifying the question that they gave us into a way that we can integrate it really easily. And so then from there, we have a third t to the power of, sorry, not to the power of, with our answers being this. And then we have okay, so then we just have to sub that in, and we're gonna get a half minus a third plus 7 on 9 minus 5 on 8, and that gives us a probability of 23 on 72. So yeah, that's our probability, and that's kind of how that works. Again, try not to overthink these kinds of questions. Think about what you know about a probability density function and work on it from there. Okay, bivariate data. This is again something I did not really think about when I was doing it, but I think it's super helpful to just revise it so that you can remember how to put the correlation coefficient into your answer. So Manoj, can you put a poll up? And then this is our last question before a break, and then we go into our final block. So that's super exciting. Also, constructive scatter plot, like in the HSC, they would give you like grid paper, and they would say like point exactly, put all the points on. But for this, I'm just gonna do it super ad hoc because it's just to prove a point about the correlation rather than actually do it super specific like you would have to in the HSC. Manoj, are you typing an answer to that question in the chat? Okay.
Gotcha.
My advice would just be, I got super stressed about year 11 prelims. And then it took me a while, but I realized that your ATAR is not the end of the world. There are other things in life that are more important. So if you screw it up, then you're not gonna die. Like you'll be okay. It'll be okay no matter what happens, is what I would tell them. How much longer do you think people need?
Probably a little while. Not too many people have answered yet. We'll give them a bit more time.
Yeah, you have to plug all those numbers into your calculator, so fair enough. I completely forgot. Yeah, no, that's why I put the question in, so that we can remember how to work out what buttons to press. It also depends on whether you have one of the like Casios that are black or one of the Casios that are silver. They're slightly different buttons, but I'll go through it when I answer the question.
I think we've got quite a few answers, but yeah, feel free to answer whenever you're ready.
Okay, awesome. So for this, we're just gonna have, I'll draw, as I said, I'm not gonna draw this like to scale or anything, but more or less your dots would kind of look like something like this. That probably makes it look like the correlation is stronger than it is, but you get the idea. So then what we're gonna have here is the buttons. You have to, so you've got your stats and you've put them all in, like you've done your mode and all of that. And then what we're gonna have to do is, so on the gray calculator, if you have like the most recent calculator, sorry. Once you've got your stats in, you're gonna click the shift button and then you're gonna click 1. So you've got your like menu open now after clicking all clear, so your data is not like on the screen. And then after that, for the calculator that I have, I know that I think it might be 4 on the other one, but for us it's 5. So you get your like regular, like it would say like REG, and then your options will come up with a whole bunch of them, and then 3 is the little r. So this should be like regular here, and then this should be like the little r. So whatever button is the little r is the one you want to press, and then you'll get it. And so for this set of data, you get something like this. And did it say what? Yeah, 1 into 3 decimal places. So you got it like this because you want to round up with the 8. Awesome. And then for part C, you want to describe the relationship. So when you're describing a relationship, there are 3 things that you need to include. You need to talk about its strength, which is what the correlation shows us. You need to talk about the direction. Is it positive or negative? And then you need to talk about the type of relation. Is it linear? Is it nonlinear? Anything like that. So in mine, I said, I put it just to this because I couldn't be bothered to write it all out. But if you remember, the specific is from here to here is considered strong. And then so that's like your strength. We know that it's strong. And then we know that it's negative because we've got that negative sign. You can also see it if you look at the graph, and we know that it's linear. So those are the 3 things that you need to say to get the mark for that part of the question. Okay, awesome. So now it's time for a short break. Get a drink, stretch your legs, do whatever you need to do. Ask any questions that are on your mind. Anything about exam techniques, the ATAR, maths, anything like that. Just shoot a question to the chat and then we'll get going on our last content block. I've run out of iced coffee. That's really sad. And we're going to continue on stats after this break, but the next question is multiple choice. So, yay. Okay. So we've got a question that's just been sent to the host about ranks. If your ranks are not great, is a 90 plus ATAR possible? Yeah, 100%. It really is up to what you do on the day. So your internal and your external marks are going to be averaged out. So if you got a super high external mark, then no matter what your rank is, it's going to be brought up. So just keep trying. And yeah. Oh, okay. I learned this. My dad told me this about someone's asked if your calculator keeps dying. What you can do is your calculator is actually solar powered. So sit it on your windowsill during the day and it will charge it for you. How crazy is that? Yes, we can go back a slide. Sorry. But your calculator is solar powered. So literally just put it under the window and it will charge. And otherwise, if that doesn't work, just like slap it on your knee. You'll probably be like sitting in your HSC exam and you'll just hear this like thud and it's someone like hitting their calculator. I was once on a science tour with a bunch of my friends and my friend was sitting like 10 rows back of the plane and you just hear this and she was doing her maths homework and she was just hitting her calculator. So yeah, those are my fun calculator tips for you. And yeah, try not to stress too much. Year 12 is awful, but would you suggest to use 2 calculators in the exam? I brought 2 into my exam just in case. I also brought like a million pens just in case. If you don't have an extra one, that's fine. Don't worry about it. But yeah, just bring it in case something goes wrong. They will check your calculators, so just make sure you don't have anything dodgy on either of them. Um, but yeah,
Cool.
are we
Don't think
happy
there's
to
any
go
more
on?
questions. Yeah, might as well go on.
Okay, awesome. So the normal distribution. This is how we get graded, if anyone was aware of that or not. This is how they work out. It's the bell curve, if you've ever heard anyone talking about that. So I'll give you a couple seconds to do this. Can we get a multiple choice going? I'm just trying to make sure we cover as many bases. Yes, financial math is the last question at the end of the slide, so stay tuned. I'm getting to it. It's like an application of sequences and series, more or less. So I just put it in with there. Yeah, if you're worried about this, if you're a little bit confused, try and work out what the z-score is. That would probably be my best advice. And remember that we're looking at our bell curve. So it looks like, why did I draw that? That's so not what I wanted to do. Okay. So you have your whoop, that looks like this. And so on. That's like such a dodgy drawing, but you get the idea. Are we getting many responses, Manoj?
They're coming through slowly. We'll give them a little bit more time. Cool. Okay, go for it.
Can you share the answer so we can see?
Mostly was B.
Oh, look at you all go. Okay, well, I won't go into too much detail of this because you all got it right then. Yay. But okay, so we know that our mean is this and our standard deviation is this. If we plug that into our z formula, we get so our z-score is -2, which is like this one here. This one here, and we're going to try and find out what this is. So we know our rules of symmetry for our normal distribution. So from 2 to 2, that's going to encompass 95% of our scores. And so then the leftover half is going to be in front and half is going to be at the back. So we've got 5% left over. We want to divide that by 2. So we end up with 2.5% left over. Awesome. Good job, guys. So let's quickly move on. A Pareto chart. Oh my goodness. I totally forgot about this in my study. I don't know if I've like skewed the questions to things that I just forgot about, but hopefully other people find them useful as well. I'll give you a couple seconds if you get a poll going of how people are finding it. I'll zoom in so you can actually read what that chart says. And if you can't remember the Pareto principle, we'll go through that for part B. Also, if you can't tell, I took a photo of the paper that I'd done, so it's got a hint in there. In the HSC, you wouldn't have that line that I've drawn.
Answers are slowly rolling in. We'll give people a bit more time.
I'm really bummed that I've drunk all my iced coffee. Is the z-score and standard deviation the same thing? Not quite. They're the same principle, but they're done differently. So you use your standard deviation, which is okay. So if you have your z-score, you have x minus the average divided by the standard deviation. So that's what your like denominator is. So that's about the question before. Would you measure rectangles from the corner or the middle? Whoever asked that, would you be able to like clarify your question there? I'm not quite sure what you're asking.
You're good to go over it whenever you're ready.
Okay, I'm trying to erase this, and the eraser just like does not want to. That's just gonna stay there apparently. Sorry about that. Okay, so what percentage of people complain? So the way you read a Pareto chart is this is like the actual numbers, and then this is your percentages. So you would just intersect your thing and go along this line, and you find that that would be 65%. So that should be fairly straightforward. But then the second part is what's actually more complicated about it. So that would be 1 mark, and the next bit would be 2. And this is where you have to so this for part B, this is where you would have to write like a word answer for a statistical question. I used to hate these, but there's a pretty simple formula to getting the full marks for it. So you want to state your principle and then you want to apply it, because this is a 2-mark question. So the principle is the Pareto principle is that 80% of complaints come from 20% of issues. So that's where your first mark would be in stating the principle. And then you would say, as a majority of complaints come from delivery, you would fix this by addressing that first. So that's a pretty straightforward question, but it's just about stating the principle to get the full marks for that answer. Okay, this is supposed to say arithmetic. I literally do not know why I wrote that there. I also can't spell arithmetic, so we're just gonna go with it. Whilst you do that, if we get a poll going, I will answer the questions in the chat. Can you give us tips on how to minimize silly mistakes? Okay, so minimizing silly mistakes really comes down to looking at your paper with like fresh eyes. Oh, sorry, zoom in. Yes, I can. So what I would say is, I'll go back in a hot second, but if you could just, so I've got that. Okay. So what I would do is I would go through my whole paper and answer it like start to end. And then you just need to make sure your brain is actually switched on when you're checking. Because when you're checking your paper, I know before year 11, like year 10 earlier, I'd just be like, oh yeah. And I'd just read what I wrote and I'm like, oh, that makes so much sense. Yes, I'm totally right. But what I ended up doing after that was like covering my answer with my hand and then rethinking through the question. And if what I thought the second time I did it was different to the first, that's when you really have to pay attention to what your answer is. So just try and cover up what you've initially wrote when you've checked it, when you're checking, so that you're not like just lulled into a false sense of security of, oh yeah, that makes sense. Okay, so that would be how I would minimize silly mistakes. Should I do multiple choice at the start or end of the test? I would say do it at the start because it's meant to be a warm-up. So it's like organized that in that way for a reason. It's not like English where it's just organized in terms of, it's not just organized in terms of like, oh, this is each module. It's not increasing difficulty. This is actually supposed to be increasing difficulty. So do it at the beginning is my advice. Also, I normally did the multiple choice in the reading time and just like remembered, or you're not really supposed to do this, I don't think, but like used my pointy nail to like scratch the paper where I thought the answer was. Because you're not allowed to write, but I didn't say that. What? And then you don't get the probability topic. Any tips? What I would say is how I did my study notes for maths is for each section of the syllabus, I would do a 1-page summary. So everything that you need to know is on that 1 page. So go through your textbook with any probability stuff that there is, find any principles, find any rules, and put them on one piece of paper. And then when you're answering probability topics, have that like next to you until you kind of understand what's going on. That's how I would say would help there. Would we get a lot of worded questions? What we are assuming from, because this only been examined once, is yes. If any of you have seen the cricket question, they gave us a literal whole page of information about crickets and then asked us to do like a 2-mark question about it. So it was it was a question about like the frequency of chirps dependent on the temperature. So they told us all sorts of things about crickets, about how crickets are louder when it's colder and random things that we didn't need to know, but you have to like weed out the relevant information. So my answer to that would probably be yes. Okay, how are the responses going?
Looks good. I can go for it.
Awesome. Okay, so we know that this is an arithmetic series because I wrote that in the title. But you should probably prove it, which you would do by just showing the common difference. But we know that our first term is 48 and our last term is 33. So our formula for this is Tn equals a plus the difference times n minus 1. And we also know that our first term is equal to a, because if you did 1 minus 1, then you would have 0 times the difference. So this is just going to be 48. So we can sub that into our equation and we get 48 plus d n minus 1. In the questions, they asked if there are any sessions like this for extension maths. Not this time around, but we're just trying to see what demand we had. If you do want extension maths, we have some awesome tutors who would be willing to do like group sessions if you prefer that. Okay, so now that we have this part of the question, what we have to do is we have to sub in this. So we know that n is 7, and our answer is 33. So we have 33 equals 48 plus d 7 minus 1, which is 6. And then we're going to subtract the 48 to the other side. So we have 6d equals 33 minus 48, which is negative 15. So d equals negative 15 divided by 6, which is negative 5 on 2. Okay, so now we have our whole formula. So we're going to have Tn equals 48 minus 5 on 2 n minus 1, which is what we need to answer the next question. So it asks us what our fifth term would be, and literally all we have to do is plug in 5 into this equation. So that'd be 4 because it's n minus 1, and that gives us 38. And do not forget your units. That's a huge silly mistake. I do one sweep of my paper at the end, which I'm only looking for units. So if whoever asked about silly mistakes, that's my biggest advice there. Remember your units. And then for C, if we want to extend our ladder, what's our minimum? So for this, we're going to set our answer to equal 0, and we're going to work out what n is to work out what the total number of rungs we could have before the rung doesn't exist. And then we're going to subtract what we already have, because we know we already have the 7, and then work out what that is. So we'll have 48 minus 5 on 2 times n minus 1, which gives us 48 minus 5 on 2n plus 5 on 2. So, and that's 0. So then n, sorry, I'm just trying to get through this quickly, n equals 20.2. So obviously rungs, you can't have 0.2 of a rung. So we're going to have our smallest rung is going to be the 20th one. And so from that, our max rungs is 20. Therefore, 13 more can be added. Okay, awesome. For the person who was asking if I can go back, I'll keep this up for like 5-ish seconds and then we'll move on to our next question. We'll do one geometric series and then we'll do financial maths and then we'll wrap up. Sorry for going a little bit over time, but I just want to get through these last couple of questions. Okay, so could we get a poll going for what people get for this? Yeah, okay, we'll do this one. This is going to be a bit of a long question, but I'm not going to give you enough time to answer the whole thing, but get a head start and see if you can beat me to the answer. Okay. Give you another like 10, 15-ish seconds to start this. If you're stuck, we've got our formula is this for a geometric series. Okay, are we happy to get going? Okay.
Another like 10 seconds, maybe.
Yeah. Okay, I'll just leave my tea there. Just hang it.
All right. I think that's all right. Go for it.
Okay, so we know that T4 minus T2 equals 48. So let's work out what T4 and T2 are. We've got A times R to the 4 minus 1, which is 3, minus A R, and then we have 2 minus 1, which is just going to give us 1 equals 48. So let's take our common out in front, and we've got R squared minus 1 equals 48. Okay, so that's like our first thing there, and then we're gonna get our T6 minus T4 equals 432, and so we're gonna do something similar here. We've got AR to the 5 minus AR to the 3 equals 432. So we can take AR cubed out the front, and we get R squared minus 1 equals 432. Okay, so we now have, what I'm gonna do is I'm gonna, how's the best way to do this? Yeah, so for here, R is gonna be 48 on A R squared. And then we're gonna subtract 1 and do the root of all of that. And then we're gonna do the same over here. So R is gonna be 432 on AR cubed plus 1, and then do the root of that. So I missed a couple of lines of working just to try and do this as quickly as possible. And then because we have 2 equations with R, we can just equate them. Space, Jesus. Okay, so then we're gonna have the 2 of these, because they're both squared, we can just cancel out the squares and do 48 on AR squared plus 1 equals 432 on AR cubed plus 1, and then the plus 1s cancel each other out, and then let's cross multiply. And then we can cancel out our A's, and we can cancel out this R squared, but we still end up with 1 R on this side, so we get 48 R equals 432. And then from that, we have our R left over, and we divide them out. So we get R is gonna be R9, but because there's one thing, remember that we had, these were the roots. So we need to, this is actually gonna end up doing the squared because we've got rid of our roots, so we need to bring them back in. And we're gonna end up with R, so this should be more or less R squared basically. And then we're gonna have plus or minus 3. R is greater than 0, therefore R equals 3. That's our common ratio there. Okay. Sorry that was super quick, but I just wanted to get to this financial math question so we can cover off all of our dot points. So I'll give you a couple seconds. We're already over time, so if you want to head out, that's okay, but we'll just go through this super quickly. Actually, I'm not going to give too much time to start this because we are over time. So let's start out by writing what we know. We know that our principal is $600,000. We know that our N is 25 years, but we want it in months. So we're going to have 300 months. And we know that our little r is 0.048 per annum, but we want it per month. So we're going to have 0.004 per month because we have to divide that by 12. So our capital R is going to be 1 plus that, which gives us this. So that's the introductory information that we have. What we don't have is our M. That's our question mark. So to do the first one, our first amount is going to be A1, which is going to be our principal, times our capital R minus our monthly. And then our A2 is going to be, this is like this, our A1 acts as our new principal. So we're going to have PR minus M, and then we have to times that by R minus M. And then we're going to have, if we expand that out, we're going to have P R squared minus MR minus M. Now we know what P and R are in this case, but we just want to make sure that it's the simplest way possible to write it out. So I'm going to leave it in algebra at this stage. But then because we want to know how much is owing after 2 months, that's when you can sub it in. So if we subbed in 6,000 for the P and the R of 1.004, then we would end up with 6,000 times 1.004 all squared minus M. I'm just going to take our M out and then do R plus 1. So we would have 1 plus 1.004. And that you could leave your answer like that because it's about showing that you can get to that step, not about showing that you can do like calculations of multiplying and so forth. For part B, we're going to do our A3, work out what this is. So we've got P R squared minus MR minus M, which is our A2, and that becomes our new principal. So then you have to times that by the rate and minus the monthly repayments. And so this gives us P R cubed minus MR squared minus MR minus M. And what we can see about this is we've got a common factor of M, which we can take out, and we get R squared plus R plus 1. So to make this, what you can see here is that the R squared plus R plus 1 is almost a geometric, well, it's not almost, it is a geometric series. So we can input our formula for the sum of a geometric series here, but let's make it our general equation first. So we have P R to the n minus M, and then you want to have R to the n minus 1, and then all the way dot, 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 dot until you get down to 1. So however many R's are in the middle there. So then from that, I am running out of space. Really, I'm just going to erase. Oh my God, the eraser worked. That was so exciting. Okay, so if we draw ourselves a column and start over here, our sum of a geometric series is going to give us P R to the n minus M R to the n minus 1. Now, the reason why I do it this way, a lot of people won't do it with the algebra, but the reason why I use the algebra is because then you can just practice that proof as many times as you need, and it'll be the same for every question, no matter what the values that they give you are. So if we know that it's paid over 300 months, we're going to have 0 when n is 300. So then we sub that in and we get 0 equals P R to the power of 300 minus M R to the 300 minus 1 on R minus 1. And what we want to get is we want our M as our subject because that's the unknown. So we're going to let's put this over this side. And then we're just going to divide by that brackets there. So your M is going to be P R to the 300 divided by R to the 300 minus, not minus 1 there, minus 1 there, over R minus 1. And then we've got, because we wrote out what we know up here and we've set up our algebra properly, you can literally just put that in your calculator and you will know what M equals. And then to do part C, you're just going to use an inequality and you're going to work out what N is with the log. So just because we're over time, I will put that answer up in the recording or the answers or wherever I give it to you. But if you worked it out, you would just do your 1800,000, and then you would do that greater than your P R to the n minus M R to the n minus 1 all over R minus 1. And then you would solve that equation there. Okay, so that brings us to the end. Thank you all so much for coming and for staying this long. Can we use P instead of the number in the actual test, or would we get marked down? No, you can use P, just sub it in the last step. So that's why the algebra is so much easier to use. You won't get marked down if you do it in algebra instead of using the numbers the whole way through, as long as you remember to sub at the end. Okay, so that's all from me. Thank you so much for coming. And yeah, if you want me to tutor you or do a group class, just scan the QR code and we'll also be sending an email afterwards. So yeah, feel free to go. Thank you so, so much. And I hope to see some of you in tutoring soon.
Cool. Nicely done, Emma. That was so good. And yeah, we'll be sending out, just because a few people asked, we'll be sending out a YouTube link plus the slides and stuff sometime in the next few days. We'll try and get it done by Monday, but we've got quite a few lectures coming up. So feel free to sign up for them too.
Yeah, chemistry is this afternoon, physics is tomorrow morning, and bio is after that.
Awesome.
Thanks, everyone.
Cool. Well, we might leave it at that. Done. Good job, Emma, and hope to see you guys all later. Best of luck for the HSC.